Welcome to the deep dive. We're looking today at something quietly reshaping almost everything. Think about the device you might be listening on right now, or how your home gets power, maybe even how you get around. It's all changing, and batteries are right at the heart of it. So today, our mission is simple. Wade through a whole stack of reports on the future of batteries and, well, give you the shortcut. The key insights on this huge shift in mobility and energy.
And it's more than just slightly better batteries. It's fundamental. Batteries are really the key, to cleaning up those heavy carbon sectors, hitting those net zero goals everyone's talking about. Just to give you an idea of the scale, the world wants to triple renewable energy capacity. We're talking 11,000 gigawatts by 2030. Huge numbers. And alongside that, global energy storage needs to grow 6 times to 1,500 gigawatts. And guess what? Batteries are expected to provide like 90% of that storage.
Okay, those numbers are frankly staggering. 11,000 gigawatts. But hold on, lithium-ion batteries, they still make up, what, 98% of production right now?
Yeah.
Can we actually get there with what we have? Or are we pinning our hopes on something new?
That's exactly the tension, isn't it? Lithium-ion is, well, it's the incumbent. It works, but it depends heavily on certain materials, lithium, cobalt, nickel. And that comes with issues, supply chain risks, ethical concerns. And geopolitically, it's fascinating. You have China dominating the market right now. They've got the resources, the manufacturing scale, massive government backing for R&D. And that's really pushing the U.S. and Europe to, accelerate their own efforts, build their own capabilities. It's a real race.
Right, a technological and strategic race. So if that's the current picture, lithium-ion dominance, these big geopolitical currents, what's next? What's the big disruptor? This is where it gets really interesting, I think. Solid-state batteries. SSVs, people are calling these a game changer. The promise is, well, much higher energy density, so more power, smaller package, faster charging too. And crucially, they can be safer than current lithium-ion. We're seeing huge investment here. Toyota, VW through PowerCo and QuantumScape, BMW, Ford, Stellantis. They're all in. Commercialization, expected by the end of the decade. CATL, the Chinese giant, even wants to be making only EV solid-state batteries by 2027. This feels like it's moving fast.
It absolutely is. And, alongside solid state, there's another really interesting angle, sodium ion. Think about it using sodium, basically salt, instead of lithium. It's way more abundant, it's cheaper. So from a cost and sustainability view, it's very attractive.
Cheaper and more available sounds good.
Definitely. And it's not just theoretical. VW backed JCUA in China. They mass-produced the first EV powered by sodium ion. Delivery started early 2024. And BYD, another big player, is putting $1.4 billion into a sodium ion plant just for small EVs. It's about lowering costs and, well, hedging bets on the supply chain.
Okay, so solid state and sodium ion are the big ones to watch. Anything else bubbling under?
Yeah, a few others. Lithium sulfur looks promising for things where weight is critical, maybe drones, those future eVTOL air taxis, high energy density potentially. Then you've got zinc air, maybe for grid buffer storage. And redox flow batteries, they're already established for large-scale storage using liquids in tanks, but they're improving too.
It sounds like a lot of innovation, a lot of potential.
It is, but, and this is a big but, the industry faces some serious hurdles. It's not just about inventing the tech. The real challenge, looking at these reports, seems to be scaling up, doing it economically, efficiently, ethically. We're talking basic economic viability for some new tech. We're talking scaling problems. Something like 68% of auto companies say they struggle to keep quality high when they scale up production.
Wow, over 2/3.
Yeah, and supply chains, still risky. Over half of execs, 53%, say getting stable materials is a major headache.
Those numbers are pretty stark. Scaling difficulties, supply chain worries, and you also mentioned a skills gap. Something like 60% of execs in R&D and manufacturing are finding it hard to get the right people. That raises a big question for you listening, doesn't it?
Yeah.
How do we actually train the workforce needed for this battery revolution?
Exactly. It's a talent crunch on top of everything else. And sustainability is woven through all this. 2/3 of companies say they're integrating it, but there's still a way to go. Look at the EU battery directive. It's setting tough targets. Reducing the CO2 footprint, mandating recycled content like 6% lithium, 16% cobalt by 2027.
Which means new ways of tracking things, right?
Totally. New calculation methods for how much renewable energy is used in production. And then there's the geopolitics again. Western countries are looking at maybe protecting their own markets from cheaper imports, but they also know they need local incentives to really get things moving domestically.
So it's complex. Technology, economics, skills, sustainability, geopolitics, all tangled up. What's the path forward then? What are the solutions?
Well, the reports point towards needing really strong digital foundations. Using data, AI maybe to optimize R&D, make production smarter, and definitely tackling that skills gap, much more collaboration between industry and university seems key. Building the whole ecosystem, not just the battery cell itself.
Okay, building the ecosystem.
Yeah. So, wrapping up, the future looks diverse. Lithium-ion isn't going away overnight, but it'll be joined by others like solid state, like sodium-ion, each finding its niche, its best use case. Cars, grids, maybe even planes eventually. It's going to be a mix.
A diverse, complex future, then. So as this battery revolution really picks up speed, changing how we live, maybe even shifting global power dynamics, here's something to think about. What critical questions about managing resources, about who controls the technology, about making this truly sustainable,
Yeah.
what questions will you be asking next?